Okay, here we're going to show how we can go from a relational AI ontology based on a Snowflake database all the way to a working optimization formulation and optimal solutions for a decision problem that we would not be able to solve with SQL alone. So let's start by loading our ontology. Okay, so we've loaded an ad spend ontology, and what we're using here is relational AI's agentic optimization tools and skills with Cortex code. These are MCP tools, and we call them the prescriptive assistant because it helps with prescriptive problems. For instance, what should we do about our ad spend? So we've got some data in Snowflake. We've got this ontology already built. Let's check it out. So we can see the different concepts and relationships in the ontology. And so this is really a layer of business logic on top of the Snowflake database. We don't have a formulation yet, so let's start by looking at potential problems we can solve. Great. So this ontology is very focused on ad spend. And so we've got all resource allocation problems. For a more diverse ontology, we'd have a lot of variety of different problems we can solve. And sometimes we might need more data or to enrich the ontology, and it would flag that here. But in this case, we've got the data to solve this problem pretty directly using piecewise linear curves with segment boundaries. And so let's try to solve this. Let's do another step of analysis just to make sure we're ready to go, and then we can start formulating the problem. Okay, so allocating advertising spend, maximize total return, and looks like we're good to go just given the data we have already. So let's start by suggesting decision variables, which we will then use in our constraints and our objective. Okay, so we've got 3 different variables suggested here. So we'll add the first 2. And we don't need to include return. That'll be calculated. Next, suggesting constraints to add. Okay, so we've got constraints to do with our spend and our segment budgets. So let's add 1 to 5. Budget of 4 million. And next, we will add objective. And that budget level, for instance, we could set that at different levels and run different scenarios. So a few different options. Let's just go with the simplest one, maximize return. So now we've generated this formulation. Let's look at what's under the hood. This is all just Pyrel code, auditable, version controlled, executable. All right, so this is a formulation we built. So we built up the problem here step by step, and we can reuse this code. We can edit it, we can use it to seed future evolutions as well. So let's go ahead and validate our formulation. Okay, so the formulation's in good shape. We validated it. It's time to solve. Okay, we can see that the solve's completed, and now we can look at the results and better understand them. All right, so we can see the allocation, the optimal allocation we found, demands to the diminishing returns. And then we can look at the full solutions as well and export them back to Snowflake for further use. So we've got a summary of the solution, some examples, and key observations on the allocations. So let's see what happens if we want to run multiple scenarios. We did 4 million. What happens if we run 2 million and 5 million? And so we were able to run multiple scenarios here. So we had our original 4 million, run 2 and 5, and we can see the key insight here, diminishing returns are evident. And so let's dive a little deeper into the solutions. Okay, and finally we can look at our scenario analysis. So we've got diminishing return patterns here, key findings, and we can keep iterating on the formulation and run different scenarios, or we can just go solve new problems based on the same ontology.